Hi guys, it's Miss McQuaid here. So I wanted to go over with you some things from the lab. So I'm going to just go through them here on this whiteboard. All right, so in our lab, we mix together sodium hydrogen carbonate, which has the formula, there we go, there we are, NaHCO3, and that was a solid. We added that together with our hydrogen chloride or hydrochloric acid, HCl, and that was an aqueous solution. Now, this goes through a weird kind of double replacement reaction almost. So, when they get together, the Na and the hydrogen carbonate break apart. The hydrogen and the chlorine also break apart. But it's a little bit more complicated than just a single replacement reaction. So I wanted to show you what's happening with the hydrogen carbonate and the hydrogen. All right, so the other side of the reaction, this positive and this negative ion are going to find each other in the solution, and they're going to form NaCl. It's going to be Na plus and Cl minus. We don't need to crisscross those. Now it tells you in the lab that we also create water and NaCl. I'm going to show you how we make those two molecules out of our remaining hydrogen carbonate and H plus ion here. So hydrogen carbonate is kind of a weird molecule. So let's break it down. First of all, we have a carbonate. So I'm going to break this apart into H plus and CO3 minus 2. So this is my hydrogen ion and this is my carbonate ion. All right, so a carbonate ion actually is bonded like this. There's one double bond and there are two single bonds. And there are 1, 2 lone pair electrons, 1, 2 lone pair electrons, 1, 2, 1, 2. So here I'm showing altogether 24 electrons. Carbon contributed 4 electrons. Each oxygen contributes 6 electrons. So there's 18 oxygen electrons and 4 carbon electrons. And then since carbonate has a -2 charge, I know that it started out with 2 extra electrons. All right, so now in solution, this H plus is floating around. It's going to attach here. So all these negatively charged electrons, that H plus is going to attach here. Now if we go back up to my reaction, you'll see that Na and Cl are already accounted for. Here is hydrogen carbonate down here. The other hydrogen atom will come in, and because this oxygen is more negative than this oxygen, notice there's more non-bonded electrons around it. The other hydrogen is going to hang out like this. Now since they're attaching, they're going to be sharing those electrons. So when this happens and this attaches and everything becomes neutral, this molecule snaps into 2 new molecules. So what happens is that this hydrogen is actually very attracted to this oxygen, and so they go together and form a water molecule. And what's left over, carbon and 2 oxygens, these electrons move to form a double bond, and you also form a carbon. You also form a I'm going to draw it over here. Carbon dioxide. So this molecule becomes water and carbon dioxide. So overall, our overall reaction is that NaHCO3 plus HCl yields NaCl plus H2O plus CO2. Now, in terms of balancing, everything is in a 1-to-1 ratio. There's one sodium atom in the reactant side. There's one sodium atom on the product side. Here is one hydrogen plus one hydrogen, and 1 plus 1 is equal to 2. And on this side of my reaction, I have two hydrogens. Sodium, 1 and 1, hydrogen, 2 and 2. Carbon. On this side of my reaction, I have one atom of carbon. On this side of my reaction, I also have one atom of carbon. Now here, on the left side of the reaction, I have 3 oxygens. On the right side of the reaction, I have 1 oxygen in the water and 2 oxygens for my carbon dioxide. So I end up with 1 plus 2, or 3. So all of these are going to react in a 1-to-1 ratio and produce a 1-to-1-to-1 ratio. So 1 mole of sodium hydrogen carbonate reacts with 1 mole of hydrochloric acid to produce 1 mole of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide. So once you know the number of moles of sodium hydrogen carbonate that you used, you also know that that is the same number of moles of sodium chloride that reacted.